Hey guys, still in Unit 6. We're still working with multiples of 10. And today we're going to look at writing it with exponents instead. And you've seen before, if you see like 10 to the third power, this part is the exponent. This tells you how many times 10 was multiplied. So it would be the same as 10 times 10 times 10. Okay? 10 times 10 times 10. So that little exponent up there just tells you how many times this number is being multiplied times itself. And on this page, you are shown a big snowflake. And we're asked to determine what do we notice about this snowflake? The first thing I notice about this snowflake is there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these. So we have 10 of the big spikes. And then if I go out to the end of the spike, on the end of each one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 other spikes. And then if we really get in close, we can see that on the ends of those spikes, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little spikes. So this whole snowflake would be 10 to the third power because there's 1, 2, 3 sets of little 10s on here. And that would be like multiplying. So I would have 10 times 10 is 100 times another 10 would be 1,000. So look at our power. Look at our exponent. It's the same. The exponent is the same number of zeros or the same numbers of multiples of 10 that I have. Okay? So let's keep that in mind. The exponent was the same as how many multiples of 10 I had in my final answer. Okay, so let's move on to page 155. Page 155, it says about 1 million people, well, I just told you the answer, about 1,000,000 people live in Delaware. And it says, how do you say this number? Well, we know that these are hundreds and these are thousands, and that would be 100,000. So if I go up to the next one, then that's going to be 1 million. Okay, so I would say that number is 1 million. And it says, how many thousands is this? Well, let's look at it this way. If we were counting our place values, we would have ones, tens, hundreds, thousands, 10,000s, 100,000s, and this would be thousands. So it would be 1,000 thousands. But instead of saying 1,000 thousands, they came up with a different name to call that category altogether, and they called it millions. But it would be equal to 1,000 thousands. Okay, let's think about that. 1,000 thousands. That would mean I'm multiplying 1,000 times. And we know the rule on that. We have our 1, and then we have 1, 2, 3, 4, 5, 6 multiples of 10. And we end up again with 1,000. So if I wanted to write this with an exponent, I would have 10. How many times would I have a multiple of 10? 1, 2, 3, 4, 5, 6. So that would be 10 to the 6th power. Okay. On to question C. And we just did section C. It said write the number using powers of 10. And we said, since it had 6 zeros, that means 6 multiples of 10. So 10 to the 6th power. Then it says, how many times would you need to extend the diagram from the warm-up? Well, remember the warm-up, we had 10 big spikes, then 10 smaller spikes, then 10 little bitty spikes. So we said that was 3 multiples of 10, so that would be 10 to the third. So if I need it to be 10 to the sixth, then I would need to add 3 multiples of 10, right? I would be adding 3 more multiples of 10. All right, on page 156, it gives us a number, and it says the population, in 1997, the population of India was about 1,000,000,000,000. And it said, how would you say this number? Well, let's see. That is, we know that's hundreds, and then that's thousands, and then, let's see, this is millions. So the next category up is billions. Okay? Billions. And then it says, how many millions is this? Well, if we think back to our previous one, if this is the 100 millions place, if I went one more, I would be in the 1,000 millions place. So this would be 1,000 millions. But it's way easier to keep up with and think about it if we go ahead and once we cross another 3, we change to billions. Part C, it said write this number as a power of 10. So let me go look at this number again. How many multiples of 10 are in that number? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 multiples of 10. So if I wanted to write this using a power, I would have 10 to the 9th power. Now, on D, how many times would you have to extend the diagram from the warm-up to get 1 million tiny segments? Okay, so let's see. I think they meant to put a billion there because that's what we were dealing with. So I think they meant to put a billion there. And that would be 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so to get that number, we have to think back to our snowflake. It was 10 to the third because we had the big spikes, then the smaller spikes, and then the teeny tiny spikes. And if a billion is 10 with 9 multiples of 10, then we would need 6 more multiples of 10. Which means what in our number? It means 6 more zeros in our number, doesn't it? Because all the zeros, remember, the zeros represent a multiple of 10. Okay? Now, find the missing number that makes the equation true. All right, first of all, I know since this has a 2 and my answer has a 2, then they've already got the 2 part taken care of. So I know it's going to be a 1 something. Well, my final answer is 1, 2, 3 multiples of 10. And my problem right now is only showing 1 multiple of 10. So if my answer is 3 and my problem's only showing 1, then I know that this must be 100 because it's still missing 2 multiples of 10. On this one, the 2 part's already been taken care of, so I know it's going to be something with a 1. My answer has 1, 2, 3, 4 multiples of 10. And my problem, they've only taken care of 2 of those, so if I have 4 multiples of 10 here and 2 of them have already been accounted for, then that means I'm missing 2 multiples of 10 here. On C. Okay, if I've already got the 1 taken care of, so I know that's just going to be a 1. My answer has 1, 2, 3, 4, 5 multiples of 10, but my problem's only taken care of 1 of those, so I know that I still have to take care of 4 multiples of 10. And then in the final one, 1 times 10,000. Oh, 1 times 10,000, 1 times 10,000. Well, let's see. How many multiples of 1,000 times 10,000? How many multiples of 10? 1, 2, 3, 4, 5, 6, 7. So I would need 7 multiples of 10. They hadn't taken care of any of them over here. Okay, so I have 1, 2, 3, 4, 5, 6, 7. Where did I get 2 more? I am way off, aren't I? 1, 2, 3, 4, 5, 6, 7. 7 multiples of 10. So 1, 2, 3, 4, 5, 6, 7. All right, now we have our 3. We have our 3. So 1,000 times 10,000 gives us 10 million. How are products of 10 useful in solving these problems? Well, if we're working in products of 10, multiples of 10, every time there's another 0, that's another multiple of 10. So it makes it a lot faster and easier to solve those problems. Okay, now it says write each power as a number. Well, I write down the 1, and how many times was it, how many multiples? 3 multiples of 10, so 1, 2, 3. And we can take that and check it. 10 times 10 times 10. We know 10 times 10 is 100. And then 100 times 10 is 1,000. So yeah, our answer is 1,000. Okay, this is 4 multiples of 10. So we put down our 1, and then we have 4 multiples of 10, which means 4 zeros. 1, 2, 3, 4. The value of this number is 10,000. And then the last number, 10 to the 7th power. So that means 7 multiples of 10. 1, 2, 3, 4, 5, 6, 7. So our final number is 10 million. Okay, now beyond a billion. If we're working beyond a billion,